So I think I might do it this way and then switch it to...
Welcome to Purdue University and the CERIAS Security Seminar. Our speaker today is Meenakshi Gupta from Indiana University. She's an assistant professor in computer science there. She graduated in 2004 with a PhD from Georgia Tech, and her research interests are in computer networks and security. Are you ready?
Yeah.
We just need to click right there.
She needs to put the wireless mic on and turn it on.
We're going to go with the podium mic. Yeah, just hit that.
Yeah, my only concern is I think the movie may not play.
Oh, okay. Well, you might need to pop out of there then.
Okay. Well, this is your first seminar for the semester, right? I will try my best to make it too heavy. And if you have any questions, please interrupt. And I don't have to go through the whole thing if that's too much to go through, but we'll go through whatever you guys are comfortable
And if you do have
absorbing.
questions, if you do have questions, press the button on your microphone. The light will come on if you've pressed the button hard enough. It's right on the leading edge of your microphone there.
So this work on web security, specifically web redirects that I'm going to talk about today, was done with my students Craig Shue and Andrew Califat. With some luck, I would get a movie to play, and you will get to see them, a little bit of my lab, a glimpse of computer science department at Indiana University. And I want to, it's a very short movie, 2 minutes and 19 seconds. It was the coverage of this work on Channel 13. So I thought I would open with that so you can see how media describes things, and then I will give you the boring talk after that, right? So let's see. Okay. Let me see if I have... There's something with this movie that won't play in the slideshow mode. So
Indiana University has a new warning about an email scheme that can clean out your bank account. The 19th grade court of passing shows us new risks that support the web.
how can I do?
Open and click on any web links on this suspicious email from PayPal.
PayPal and its parents know they're prime targets for phishers, online predators who trick users into giving up sensitive personal information. It happens by a process known as redirecting. It's part of the web. You're linked to other sites, but by manipulating the code in the open links found on the address bar, phishers can send you an email with realistic-looking graphics and code asking you to confirm or update your profile.
Once you have been phished, they can log on as you to eBay, to any of your bank accounts, do bank transactions, and phishing is a very big problem right now.
Dr. Meenakshi Gupta is an IU professor who studied the problem. Some of her students wanted to find out just how vulnerable the system is. It started as curious concern between the two doctoral students here at IU School of Computer Science, but it became a semester-long, labor-intensive research project with results that surprised even them.
It's startling. There are a lot of risks to this for ordinary users.
Craig Shue and Andrew Califat, with Gupta advising, created a code that tracked 2.5 million web pages. 180,000 had redirect links. Of those, a whopping 80% were open.
So if they are open, you can manipulate the destination, take people to wherever you want, make the page look like anything you want it to be.
eBay, PayPal, and banks are the most common targets.
Most of us don't go back to the browser toolbar to see what it says.
At some point, you kind of wonder, should you just say, don't click on links in email, only go directly to the places? Because it seems like links are becoming more and more difficult for them to be able to trust.
As a bottom line, don't open a link if you don't know who it's from. Log directly onto the site or call the fraud department. That is advice from the FBI, which investigates these kinds of crimes, which really something of a difficult process because many of the phishing sites originate overseas. You can report a suspected crime online through a link at our website, WTHR.com. Live in the newsroom, Ray Quarterpassi, Channel 13, Eyewitness News.
So I hope what you did get from this short clip is that the redirect links that are present on the web can be manipulated in a manner that can be used by phishers, that can be exploited by phishers. And that's what I'll go through in the rest of this talk. If you have any questions, press the microphone in front of you, and I would like the session to be more interactive. So what is a web redirect? There are many ways there are many reasons to have redirects on the web. For example, if you have bookmarked a link and later on the website actually changes the exact directory structure on it, but they would still like you to be able to get to that original link so your bookmarks don't become invalid, the way they would do it is through a redirect. That when you click on that original link, they will redirect you to the new location of that page. That is one of the more traditional uses of web redirects. Some of the newer uses of redirects are to track users on a website. When you go to a website and you click on a link that's outside that site. For example, you go to newyorktimes.com, but they have an advertisement that you click on, so you get taken to that advertiser site. In that case, newyorktimes.com is not able to track where you went from their site. So what they do is, they instead, when you click, they take you to a special page, which basically allows the server to redirect you to the original site while recording which page you were at when you clicked on that redirect and where you went from there. So tracking of users is a big thing in the internet, and redirects are a common way to accomplish that. So a site could have a special redirect page, record where you were going, and basically know where you went from their site. So that's another redirect. Another common use for redirecting is to prevent what's called typo squatting. So popular domains, for example, eBay, Google, they have people who want to leverage their brand names in doing bad things, or at least serving up advertisements. One of the ways they would do it is they would register something like google.com instead of google.com. And when people go to google.com, you can show them advertisements and such. One way that Google and other brands, eBay and banks even, would protect their brand is to register the variants of their domain name. So Google would register google.com, G-O-O-O, google.com kind of thing. They try to register as many of these as possible. When you click on them, then you no longer stay on google.com or google.com, you actually get redirected to google.com. And that's, in fact, one of the very popular reasons to have redirects. So to find relocated content, to track user visits and where users go from your site, and to prevent people to redirect people from typo squatted domains to your original domain are some of the prominent reasons to use redirects on the web. So it's a very powerful feature of the web, the redirects. Unfortunately, if you don't make your redirects, provision your redirects properly, they can be exploited, and which is what the study is about. So we basically had 3 goals in this work. The first was to develop heuristics to identify redirects that are open and can be exploited. The second was to find how many of such open redirects actually exist on the internet. And the third was to look at techniques that would mitigate these open redirects. So my goal today is to at least go through the first 2 bullets, and time permitting, I'll go through the third bullet. So in what way do you actually accomplish a redirect? How does redirecting really happen? There are 3 common ways of doing redirecting. One is the HTTP redirect, where the server, when you click on that link, the server would actually send us HTTP status code, and along with that response, tell you where you should go, right? The second way is the HTML refresh. There is a HTML refresh meta tag that allows people to, it was really provisioned for refreshing that very page, but it allows you to actually go to another page. So if you refresh, you can be taken to another page. And that's another way of accomplishing redirect, not the most popular one. Then, of course, you can use JavaScript to practically do anything, and one of the things you can use the JavaScript to do is to take you to another website, and that's another use. So in this work, we basically focused on HTTP redirect, which is where there's a status code, and the response contains the site where the client should be going to. And We just focused on that particular way of approaching, accomplishing a redirect. Now, irrespective of how you accomplish your redirect, the redirect is either static or it's dynamic. What do I mean by a static redirect? So here's a link that cannot be changed in any way. Anyone and any time that link is clicked, you get taken to a fixed web page. So there's nothing you can do to the link that would cause you to go elsewhere. And in general, you cannot look at a link and determine that it's a static redirect, or this kind of a redirect cannot be inferred unless you actually traverse the link. Does everyone get that? So by looking at the link, you don't know it contains a redirect, and even if you traverse and find out it's a redirect, there's nothing you can do to change the destination of the redirect. That's hard-coded in it. So static redirects cannot really be manipulated in any way. However, dynamic redirects, which is what we studied, can actually be manipulated, and that's what we looked at. So for the rest of the talk, we'll look at HTTP redirects that are dynamic in nature. So what is sort of the anatomy of a URL that contains a dynamic redirect? A dynamic redirect will oftentimes have the destination where the client is being taken to as part of the URL. And when a user clicks on such a link, the web server extracts the destination from that query string and uses it to actually determine what the response code should be in the HTTP response and what the destination should be in the response. So here's an example of a dynamic redirect. So this is, you're actually going to ebay.com, and there's a server-side script, which you can see is redirect.php here. All the query strings in HTML have to have a question mark that precedes the parameters of the query. So that's the question mark. And then in this particular case, it's very evident that ebay.com is actually redirecting you to fisher.com, right? So by examining this link and by looking for a question mark character, then you know that you're actually being taken to fisher.com. And this is one of the simplest examples of a redirect URL. And so in general, there will be a question mark in a link containing a dynamic redirect, followed by the destination of the redirect and some other parameter values. For example, the client was coming from this kind of a browser, they were coming from this kind of a zip code, or they entered this search string. If you, next time you go to Google, go back to the browser location bar and see what it looks like. There will be a question mark, there will be a destination, and there will be your search terms with pluses, and those are all query parameters. That's the way in HTML to specify a query. And a dynamic redirect makes use of the query parameters in a URL. So what we want to do is find out, given a link, does this link contain an HTML dynamic redirect? That's our first question, right? Only if it's a redirect, then we would go and explore if the redirect is indeed open. True? So what we did was so given a link, how are we going to determine if it contains a dynamic HTTP redirect? We are going to look for URLs that contain query string. And how do we determine it contains a query string? Question mark, right? Now, then we check if the query strings contains an HTTP : or HTTPS : which means that that's a web destination. That means for sure that's a web destination. Of course, things are a little bit more complicated than that. First off, HTTP doesn't have to be written in English. It could be hex encoded, and the entire URL could be hex encoded. In fact, hex encoding is a very popular technique that miscreants use to misguide you. So if the same link that I showed you earlier, http://ebay.com redirect.php question mark destination equal to http://fisher.com. If the http://fisher.com was encoded in hex, you wouldn't even know it's actually a redirect link by looking at it. So you have to account for that. Another thing is we are looking for http://. There could be redirect destinations that may be relative, right? And relative URLs are perfectly acceptable. But let's just go with this very simple, very conservative way of finding HTTP dynamic redirects and see what we get. And that's where we are with this project. So now we have found a HTTP redirect that's dynamic because it has a query string and such. How are we going to make sure that it's indeed a redirect? There could be things that you come up with that are not redirects. So what we do is we actually, through a library, we follow the redirect and determine if the destination of the new page matches the destination we thought it was going to take us. Right? So looking at the URL, you determined it's going to take me to fisher.com. You traverse that redirect and look at the final destination on your browser location bar, and if they match, then you say, yes, A, it was a redirect for sure, and B, I was able to determine the destination of the redirect accurately. Okay? Now, this is a simple kind of redirect, as in looking at the URL, you could actually determine the destination of it. And that too not when the parameters are, when the destination is relative. Right? There are indeed more complex forms of redirects that we did not look at. You could have one redirect taking you to another redirect, and that redirect could be redirecting you somewhere else. So there are more complex cascaded redirects, as well as a dynamic redirect leading to a static redirect, but multiple redirects could be occurring. But we are just looking for one web server taking you to another web server. So redirection could be in a chain of redirects, but we are only looking for one redirect, that too where you can predict the destination of the redirect by looking at the URL itself. So really, if you think about it, this is scratching the surface of the problem. There are many more ways you can do redirects. It could be relative. We do take care of hex encoding, but other than that, complex forms of redirects we have not examined yet. So we are looking for redirects that are very simple, destination is predictable by looking at it, and they're dynamic and HTTP based. So really a small subset of the total world of redirects that could be happening on the web today. Now, how are we, given a URL, we came up with very simple ways of determining whether it is a redirect or not. But not all redirects are open. So how are we going to find out if a particular redirect is open? So what we do is we look at the query string portion of the URL and we replace the destination with the destination we control. So we have our own web server. We basically, any link that was a true redirect, simple redirect, we replace it by our own page. If the link actually takes us to our own page and not the destination that originally was there in the link, then it is open. Right? It's open because you can manipulate the destination and take people wherever you feel like. To make sure that they were indeed taking us to a page, we didn't just look at the location toolbar on the browser when we were taken there. We also had a random character string, which typically would not appear in any good web page, just a random hashed sort of value that we checked was the value we retrieved. So we were indeed at the page where we thought we were. Because keep in mind that we are not verifying these things on 5 or 10 links. We are verifying these on millions of pages. So it has to be done in an automated manner. Okay, so I just told you how you would take a URL and modify the destination and find out if it's open. In some cases, modifying the destination may not work, as in the URL is not, the redirect is not open. But it turns out if you messed with the URL just a little bit, you can make it open. You can pry it open. So one, it's open, you manipulate the destination, take people wherever you feel like. 2, you can tweak the URL just a little bit and you can make it open. And in either case, it is open, right? So how did we pry open these redirects? One is query parameters typically are more than one. In fact, in typical cases, we found up to 4 query parameters. Once you see a question mark, there will be a destination, there are other parameters as well. In some cases, what we did was just drop the query parameters. the rest of the query parameters and see what it does, and then manipulate the destination. The other things we try to pry open, and these are not the most exhaustive set of things you could try to pry open a redirect. We tried some very naive things, if you will. So the other things we tried was we dropped the other query parameters, and either we dropped them or we altered them in very trivial ways, which I'll describe. So what have I covered so far? Given a link, you need to have some heuristics to determine if it contains the HTTP dynamic redirects, because that's what we are focusing on for now. And we looked at only a subset of it, which is simple redirects, where you can predict the destination of your redirect by looking at the link itself, and you verify it. So you actually traverse to make sure that your redirect is actually a redirect and it's a simple redirect. Once we confirmed that a link contained an open a redirect, we applied very simple heuristics to either find if it's open or to tweak it just a little bit to see if we can make it become open. Right? Okay, so now for how we went about actually conducting the study. This is sort of the background. We actually did web crawling. So we started with a list of URLs. We downloaded that page, all the links on that page, and all the links from that page, from those links. So essentially 2 levels deep. And we stayed within the same domain. So if the original link was ebay.com, you go to eBay's first page, you retrieve all the links on that HTML page, then you take those links, but then you traverse those links 1 level deep further, and then you get another set of pages that have other links. We retrieve those links also, but we did not click on the link if it was taking us to another domain. So if ebay.com has a link to paypal.com, we did not traverse that. Staying within the same domain, we basically did 2 deep on every page that we traversed. And then we had a big collection of links. Then we applied our heuristics to find redirects, to verify that we were correct, just simple redirects, and to pry them open and to find if they're open. So we used 3 initial URL lists because we wanted to traverse it's a small fraction of the web for how big web is, but we wanted to not do a few hundred or a few thousand pages. So we traversed a fairly large data set here. So Alexa is a web information service, and you can actually go to Alexa to find out what are the top 500 pages that are most popular. Or Alexa has 16 different categories. You can say what are the 1,000 most popular pages in each category. So what we did was we looked at top 500 popular pages on Alexa and top 1,000 pages in each of the 16 categories that Alexa has. Then this is one data set that we use for original list of URLs. The second list that we use was, there is a DMOZ Open Directory project. So this is a project that has the goal of collecting URLs that people visit. So a URL that you often visit or you visit, you may contribute that URL to the DMOZ directory project, Open Directory project. And they have, I think not that many really as proportion of the web, but they have many million links that users have contributed, and anyone can download those links. So we found user submitted links from that, and those were all our starting pages. So these are 2 sets of starting URLs we used. The third list of starting URLs that we used was DNS queried issued by our department. So if we saw a URL, a domain that people traversed, we looked at which domains they went to, and we started with those as first pages as well. So these were the 3 data sets: popular web pages, the pages that the domains that people in our department traversed, and the links that were submitted to the DMOZ Open Directory project. So we hope that this gives certain sampling of the web as it exists. So in Alexa data, we had close to 1 million links, million pages that we started with. DMOS, we had a smaller set, 216,000 pages, and the DNS actually, the domains, the pages that our users visited, was actually the largest, which is close to 1.4 million pages. So these are the number of pages. So how many links did we end up with? This is close to 140 million total links that we actually examined for the study. It turns out that 70 to 75% of them, at least 2/3 to 3/4 of them, don't have a query string, which means they don't even have a query string, so they can't be a redirect. And they can be a redirect, but they cannot be a dynamic redirect for sure. So we eliminated at least 70% of the links from each of these data sets. And even when there was a query string, in many cases, the query string did not contain a URL pattern, which is there was no http://, which doesn't mean that it cannot have a dynamic redirect. However, given that we are looking at just a simple dynamic redirect, it certainly did not have a simple dynamic redirect. So we ruled those out. So out of the 140 million links that we started with, somewhere between 1 to 2% of those actually looked like what could be a redirect, dynamic redirect, right? So we looked at those. Then, well, remember we said for query strings, we'll look at a question mark, and then we'll look for http://. So when we looked at that, then those 1% numbers, if you remember from the previous slide, you don't remember those numbers. We had a little less than 300,000 potential simple, dynamic simple redirects in Alexa, 20,000 in DMOS, and about a little over 500,000 in the DNS data sets. So how many do we have? 850,000 or so links that contain dynamic and simple redirects. We haven't traversed them yet. All we think is using our heuristics, these should contain redirects. And then we actually traversed them through a library and verified that the destination contained in the link, whether that was the same as the destination in the location bar after we visited, right? So it turns out that our heuristics actually identified somewhere between 58 to 68% of the links that we thought contained a dynamic redirect actually did contain dynamic redirect. But the others, they were not what we thought they were. But out of these 850,000 potential redirect, 2/3 of them were actually redirects. So our heuristics are reasonable heuristics to identify a redirect. The rest were either not redirect, and it turns out that some of those links are broken because these data sets are not real time. This link that you have in DMOS was maybe submitted a year ago and maybe isn't active. Not everybody is making sure that every link they promote on their website remains active, right? So it turns out for DMOS data set, if you notice, there were about more than 1/5 of the links were actually broken by the time we traversed them. So the fact that we only see our heuristics identify 2/3 of the links as redirects doesn't necessarily mean that the heuristic is bad, because in quite a few of the cases, the link itself is broken. But here we have some redirects that are simple, so you can predict the destination of the redirect, and they're dynamic, and now we want to test if they're open. True? So essentially, across these three data sets, we found over 500,000 actual redirects, actual simple and dynamic redirects, which means, once again, that there is a destination contained in those links that matches the destination of the final page that you end up in, right? There was a question? Yeah.
See, you have explained a while ago, represent a sample, right? Is the sample. And so...
Did you press the mic just to be sure?
No, I didn't. Do you want me to press?
So let's start.
Yes, I can hear.
All right. So is there any kind of mathematical approach to create this sample in order to represent the whole population?
So the question is, we tried to have a representative sample of things that people would actually visit. Can you extend that to say can you sort of extrapolate it to say that what we find can be sort of extrapolated to the entire web, right?
Statistical model.
I don't know of any that can actually predict. I would be happy to know that one exists and try this out on it.
Like there are many sampling theorems, like match pair samples.
Yeah. So, well, there is a lot of web that's not necessarily traversed, and I don't know how those sampling theorems will actually tell you whether this is traversed or not. What we tried to find was what are a representative population of web pages that people actually traverse. So if somebody has done a DNS lookup, there's a client who has definitely visited that page. If it exists in the DMOS project, then certainly somebody has visited it. And if it exists as a top website in Alexa, then somebody has visited. But that would be an interesting question to think about, right? Okay, so we have 500,000 actual redirects, and they're simple dynamic redirects. And we found that these are just actual redirects, and 32% of them were simple redirects. So basically, you clicked on the link, it took you to a different destination, but in cases that you were able to identify the destination to be the destination in the query string, that was 32% of these total links. And then we apply the open redirect test, which is just take the destination of the link and replace it by a page we control and see if the link would actually, clicking on the link will actually take you to that destination. Simplest test you can imagine. And it turns out that out of the simple redirects, 83% in case of Alexa, 81% in case of DMOS, and 77% in case of DNS, which is about 80% of the simple redirects were actually open. So if the link said ebay.com, http://paypal.com, and you replace paypal.com with cs.indiana.edu, it actually did take you to cs.indiana.edu. What does this say? That means the script at the server that's processing the redirect is basically taking the destination and in the response code giving you the destination back. It's not doing anything to make sure the destination is the right destination it could be sending you to, and which is what can be exploited. Right? Now, instead of cs.indiana.edu, I can make it fisher.com, hex encoded. Even I can't actually recognize a hex encoded thing even after doing this project. It's non-trivial, right? You have to remember what the characters stand for, percentage and the character. Just imagine your mother or your grandmother trying to do that. Certainly my mother cannot do that, right? So, which means that all of these, 80% of these simple redirects on the web, you can take those links, you can replace the destination with whatever you want, then take the new link, put it in an email, send it to people. If the server it's going to originally is ebay.com, by looking at it, all of us would think you're going to ebay.com, and then you're more tempted to click on the link because you're indeed going to ebay.com. It's not going to a bad site. When you click on the link, however, the link actually takes you to ebay.com. ebay.com quickly invokes its script, gives you HTTP response code with the destination. You get taken to the new destination. The destination does appear on the browser location bar. But a lot of us, you go to a website, you click on it, after that you're more focused on the content. And maybe you could do this as a little experiment on yourself. Do you, every time you click on it, do you actually go back to the location toolbar to see where you are really? Are you indeed on a site that you clicked on? So if you go back and examine, then this particular attack can be defeated. But if you just go by the look and feel, which may be the look and feel of eBay, and don't go back to fisher.com on the location bar, then all bets are off. And that's where this whole open redirect project actually ties in with phishing question.
Can you please tell us some of the well-known websites which are vulnerable to this kind of thing, as in Amazon, eBay? Are these all vulnerable to this open redirect?
We found, I should have thought of that question ahead of time. We found open redirects on AOL and
What about
Since-
Orkut, Facebook, eBay, Amazon, the kinds of sites which phishers actually target, and
yes,
bank
there
websites?
there were sites that we found that are on top Alexa lists that are vulnerable. This includes bank sites. I don't remember the names off the top of my head. However, I will, now that you've asked the question, I'll give you a little anecdote. There is this group called Anti-Phishing Working Group, which works to prevent phishing, and you may have heard of some of their activities. And there was actually an open redirect on eBay, and since I didn't think about it, I don't have that link handy. There was an open redirect on eBay that anti-phishing, that was reported to Anti-Phishing Working Group because phishers are actually exploiting this. I don't have a measurement study saying these many emails actually exploited open redirects, but that particular link on eBay was there and was exploited by phishers, so it got reported to this anti-phishing service that they have. Now, when they get such a link reported, they actually try to close, they try to contact eBay and close that link. And in this particular case, eBay actually listened to them. And this is not old news. This happened just recently. And eBay actually closed that link. What does close mean? That you could no longer manipulate the destination to take people wherever you feel like. However, eBay has a sister website, which is called ebayobjects.com. eBay had an open redirect that got closed, but eBay Objects had an open redirect that eBay did not close. So what people did was use the open redirect to take people to eBay Objects, which was a valid functionality of eBay's redirect, and exploit eBay Objects redirect to take people elsewhere. So in this particular study, we looked at a very, very small set where a site, a web server, takes you to another site and you can manipulate the destination. However, if you know the site has a redirect and its valid functionality is to take you to sites X, Y, and Z, and if any of those X, Y, and Z have an open redirect, you can still craft this link, right? And that's the case of cascaded redirects. And that particular instance that I described, back when this story aired, I think it was 2 weeks back, I think just about 2 weeks back. 2 weeks back, I verified that eBay's redirect takes you to eBay Objects redirect that is actually open, was still alive and active 2 weeks back. And if I had thought of your question, I would have brought it and demonstrated to you that you can actually use eBay's server, who will take you to eBay Objects server, and eBay Objects will take you to wherever you feel like. And you hex encode it, there you go. URL structure is very complicated for people to decipher. Was there another question? Yeah.
Today, most of server-side technologies contain a server-side redirect. So without getting back to the client, you can simply use the server to go to wherever you want. So could it be exploited like, in the fashion you described, or?
So server-side.
No.
So in this case, the server is actually not.
He's not sending anything back to the client. He can do the redirect completely from a server-side point of view, and simply send the page back to the client.
Oh, okay.
It's more efficient,
So
by
the
the way,
server-
and it's
okay.
more secure.
Okay. I don't exactly know how it's accomplished, but I can see that one would want to do that, right? The client clicks on some link, the server says, oh, you want to go to that page, instead of giving you a status code and the destination, the server fetches the page on your behalf and gives it directly to you.
Exactly. Yeah.
So when that happens, can it be exploited as well, right? Actually, that's a safer way of doing redirects. But I don't know what percentage of servers are actually doing that. I would be interested in finding that
Very
out.
old, actually. In ASP 2.0, I guess, this functionality was.
But I can think of a business reason why you may not want to do that. So if I am eBay and I have an advertisement that I'm showing, I'm actually doing a service to the advertiser. So if someone clicks on that advertisement, I want to simply redirect them to them and not consume my bandwidth fetching the thing and then sending it back to you. So if servers were to do this, then I think it would be a safer way of doing redirects, and you actually couldn't exploit it because the server is giving you the exact page it wants you to give. Actually, so let me go back on and say one more thing about it. However, actually, it's not necessarily safer. First off, there's no business case why a server would want to do it. Two, it's actually not safer at all. If all the server script is doing is take the destination of the redirect, say, oh, you're going to cs.indiana.edu, I go to cs.indiana.edu on your behalf, fetch the page, that's actually a worst case, right? Not only are you in the first place wasting bandwidth getting people pages that they are wanting to get from your page, secondly, I could be giving you pages that I never thought I would be giving to you. So the same situation as in you need to make sure your scripts are safe and have the boundary cases covered well would stay there.
Maybe in the same domain it would be.
So, well, basically the bottom line is if you want to prevent your server from being exploited, as in people think they're going to ebay.com when all your server is doing sending them elsewhere, you're wasting your resources too. That's a TCP connection that's happening, and then HTTP and everything else. Then you want to basically write better scripts. This is along the lines of, buffer, just like you need to guard buffer overflow attacks, cross-site scripting attacks, and all other buzzwords that you hear in popular media about web security, you need to guard against this. So to answer your question, summarize the answer, I really don't think servers fetching you the page will be any more secure unless the server has boundary conditions done right, which is I should not be fetching pages beyond this whitelist, for example, which is the same thing as today. So even if the server is fetching page on your behalf, it's not preventing against this. Okay, that's a very good question. Okay, so to summarize this slide again, we basically found that it took us a while from simple redirects to do the test for open redirect. And it turns out that more than 80% were just open like that. We haven't even tried them yet, just open. Change the destination, it takes you to the new destination. Some were closed for sure, which is they just said refused. But 5%, 2 to 5% of the links were actually broken by the time we got to that. So the actual open percentage may have been more, right? Because this was done over a couple of months. Okay, so now we said these are redirects that are open just because the server script is not doing testing. But the rest, can we do something about it? So in this case, we just replaced the destination, left the rest of the query parameters, whatever they were. In many cases, the query parameters are the browser version, the language, and things of that nature. And maybe if you're searching, then there'll be a query string and something like that. So we used really as simple a set of heuristics as you could imagine to see if we can tweak the redirect to become open. And we said, drop all parameters except the URL. So after the question mark, if you saw multiple parameters, how do you know there are multiple parameters in a URL? They're separated by an ampersand, right? So if you see multiple of those ampersands, you look at the ampersand that contains the destination in a simple dynamic redirect, and the rest you just drop. So you've basically made the URL smaller. You wouldn't think that would cause the redirect to become open. It turns out it does in some cases. The other thing we tried was we altered all parameters, and let me go back to where I said what we did to alter. Okay, so I don't seem to have written that down. How did we alter the parameters? We basically, if it looked like a character, like ABCD, for example, then we just dropped a character from the end. We did not expect anything would come out of it. Or if it was a number like 1, 2, 3, 4, then we just said 1, 2, 3, 5. If it was a number, we incremented the number. And if it was a character, then we made the string shorter. So what are the 3 things we tried? In the query, there are multiple parameters. We left the destination. We changed the destination, of course. The rest of the parameters, either we dropped them, the parameters generally fell, I think all the parameters fell in two categories. Either they were strings or they were numbers. If there was a string, we made the string shorter by stripping off the last character. If it was a number, we just incremented the number by 1. Really, you would not think this would lead to anything. I mean, that was my thought, but this was the student's idea. Let's just see what the server would do. It turns out that about 2% of the links became open by this random manipulation. I mean, and this is by no means an exhaustive way of manipulating the characters, the parameters, right? Question.
But like not all the redirects actually do a URL rewrite, correct? Like you said, you'll have the key pair, like the destination is equal to the address where we're going, and ampersand the input values. But not every redirect actually uses a URL rewrite. I mean, some of the redirects, like you just click, you just see the new page, you don't actually see anything on the URL. Like what you do in a, if you use a post method or anything like that, you actually don't see anything in the URL. So is there any way you can detect, such kind of things like phishing happening?
What do you mean by you don't see anything in the URL? You do see something on the location bar, right?
Yeah, but that's like, it's not real. I mean, you don't overwrite it. You don't append anything to it.
Mm-hmm.
Whatever you pass, whatever values you pass, that's not as a part of the URL string.
What he's saying is you can pass on the parameters using a post parameter. So you won't see anything.
As in what we...
The URL remains
Oh, I
clean
see.
actually.
I haven't thought about that.
What we do when we redirect our website to Yahoo GeoCities page, as in suppose I am having xyz.com. So instead of buying web space, I redirect it simply to Yahoo GeoCities web space, but the URL remains www.xyz.com. That's what it remains.
Oh,
the
so
URL
that has to do with frames, right?
No.
No.
No, that's forward. It's forward. I mean, basically,
It's sent in the HTTP header the data and not in the query string, so that's why.
So
It's
the
like-
HTTP header in this case would not contain, the response would not contain the destination you're going to?
actually like you could either do a redirect or a forward. If it's a forward, like as you mentioned, like the initial page remains in the URL tag. If you do a redirect, actually the request is again submitted.
Yeah.
So it's
So-
kind of a new URL.
So it sounds like, of course, those are not the things that would get detected here, right? We looked at, that would be an interesting case to think as we are expanding to get hold of all possible redirects. We did not look at static redirects. We did not look at cascaded redirects where one redirect leads to another redirect. We did not look at, of course, static redirects are not very interesting from this perspective because they can't be manipulated. And this would be another thing where even for a redirect where the destination is something in the URL and actual destination is something else. And this would be one example of it, right?
Not exactly redirect, that would be forward actually.
Yeah. Those would not get detected. It would be interesting to see if you can manipulate those too. Yeah. Okay. So what we found here is in basically 2% of the rest of the redirects, simple dynamic redirects that were not open earlier could be pried open with these really trivial ways of manipulating the string, URL at all. So at the end, we had 130,000 redirect links that were very, very susceptible. So how much time do I have?
Till 20, yeah.
Oh, it's done. Okay, well, so what can you do? Today, what do the servers do when they redirect? They sometimes warn you, but...
I have one last concern to ask. As in, it's our job to protect, right? So can you please walk us through the countermeasures that we should employ?
Yeah,
so
okay.
if we are just auditing any company's website, so we can use those.
Okay. So, well, today the server sometimes warns you you are being redirected, and some of the government sites actually do it more diligently than other sites. And, if you pay attention to them, great. If you don't, too bad. Users have a way of getting desensitized if they get too many warnings. Certificate warnings, who here does not ignore certificate warnings, right? I ignore them regularly, unfortunately. The other thing is that the server could have a whitelist, For example, I'm only going to direct, Google can say I'm only going to redirect to X, Y, and Z. So it doesn't matter, even if my script that I've written is vulnerable, doesn't have boundary conditions done right, I will simply, if it's outside the whitelist, I will simply not forward it to you. Those are some of the ways that you can do it right now. The other thing is clients sometimes have a referrer header where they were before they came to you, and the server could use that. If the client was not on the right site, then if the client isn't coming from my site, which means they're not clicking my link, then that's not, I will just not forward. But of course, referrer headers has their own issues. Clients don't always supply it. Then you can secure the redirect. You can have a token in there if the token isn't there, which has your secret value. So I won't go into the details of it. Let's look at the client-side approaches. So what is done today? You have phishing toolbars, right? Google has a toolbar, and I think some of the browsers now have built-in toolbars. So you have these toolbars that have, either they look at characteristics in the URL that looks very suspicious, and redirects haven't made it to one of those characteristics yet. That's a relatively newer area. And the other thing could be it's in a blacklist, and they try to warn you against going to bad sites. And there are browser extensions that would rewrite all the redirect links. So basically, it will, if you go through a browser, of course, and it will take a link and go to the destination of it, and the link would be basically, it would be clear where you're going. So what can, as a client, you can do, right? A very simple approach is that when you click on a link and you think you're going to eBay, you go to that site, go to the location bar again to make sure you are on that site. And actually ask yourself this question next time you're clicking. Just ask yourself, do you ever go to look? I mean, this is not my area. I don't do human studies at all, but that would be interesting to find out. There have been some studies done on phishing, and actually one very controversial study was done at Indiana University where they sent emails to all students, and the email basically tried to say it was coming from other Indiana University students, not even their friends, just other Indiana University students. And that's so easy to spoof. You can have an email destination that's source that's Indiana University that just looks that way. And so many students went and gave their passwords just because the email was actually coming from an Indiana University thing. So ask yourself, when you look at a site, do you go to the location bar again? Because if you go, then you're immune to all of this. The other thing is the browser can actually apply the type of heuristics that we applied. They're not complete by any means, but the browser, if you have a version of the browser that's enhanced with these heuristics, then the browser, as you're traversing the link, can actually warn you, right? Or the browser can, the other thing the browser could do is it could look at, for example, a logo, if it recognizes logos of top brands, and you would be surprised how few top brands there are. There are just like 200-300 top brands. I mean, there aren't, compared to the more than 150 million websites that exist on the internet, top brands that are being phished are of the order of 200-300. Not that many. So the browser can have their logo, and if that logo appears on a site that's not on the same domain, the browser can warn. There are lots of such things that can be done. But redirects are really just a very new area, and even though people had recognized that a redirect could be open and phishers are actually exploiting it, ours was the first study that sort of tried to systematically go over, crawl certain number of web pages and determine how many of these are so trivial to do, anyone can do it. That's sort of the bottom line. So conclusion is that quite a few redirects on the web are open, and we have some other things that we are looking at. This was by no means a comprehensive study of redirects or open redirects on the web. We are looking at links to discover. We are trying to do more comprehensive analysis of what is a redirect. We applied some simple heuristics. JavaScript, HTML refresh are some of the other things that we didn't look at. Cascaded redirects, more complex ones. One redirect leads you to another one. And of course, a more detailed analysis of mitigation strategies. Right now, this is just sort of thoughts. If you have any other questions, I'll be happy to take them. So they were great questions. So you guys are off to a good start. Stay energetic for the rest of the semester. Thankfully, the seminar is not at 1:30, right?